Hello, friends. This is Sunil from LTTS Technology Services. Today, I'm very excited to talk about security aspects in safety critical embedded system. Right. So, all of you will, I just want to at the start make it very clear that I'm going to be focusing most part of my discussion into aerospace security and not a very generic cybersecurity. It is going to be more aligned to the product system and aircraft level security. I think my colleagues and the other speakers are going to talk about information security and other aspects. But so my focus here is going to be more on aerospace, aircraft, and system security. So before I get into getting into more details about how do we take care of the aerospace security aspects, let us look at the what's happening in the world, particularly in aerospace world today. It's a very paradigm shift that you are seeing today. You have many urban air mobility companies coming in, Joby Aviation, Blade. So all of these companies are going to be flying aircraft intracity, and that too with the passenger movement in it, right? And it's not going to be so there is going to be a different air traffic space altogether for this. And then these urban air mobility solutions are going to evolve into transportation, last mile, car, autonomous. Lot more connected system are going to come into the play. Right? You have also there are single pilot operations being discussed, and that is going to be a autonomous and also hybrid electric aircraft of feature. Hybrid electric or hydrogen, but we'll not get into that aspect. But it's going to be more safety critical, and what is key here is safety from security, right? So what is the difference between being safe and being secure, right? Safety has always been the paradigm of anything we do in aerospace, right? So now security aspect, what comes into play is more of a when there is a unauthorized access, when there is a malicious attack, right? So how does the system behave, and is it still safe, right? Safety critical is of course the utmost importance, right? And then you have low Earth orbit satellites, 5G coming in, and there is a more and more connected aircraft. And not just this, there is instead of a federated system, there are more integrated systems, right? So all of this is going to drive uh, a much more intense, complex architecture, and it's going to making sure that all of these is secure is going to be the key, because security in aerospace drives safety. So attacks on aviation are already happening. There is a airport level security. There are attacks on the air traffic control systems. There are attacks where the customer confidential data is taken out. And if you recall, in recent past, we had MH370 aircraft. We are still not really able to trace it, and we still don't know the root cause of it, right? And there was another attack that happened where the entire passenger aircraft was shot down. Recently, we also had a missile getting launched, and we call it a maintenance issue. But there are some of these things can actually happen with the cybersecurity, and it is really important that we secure these systems. Otherwise, it can be in aerospace world catastrophic, right? Compared to other areas where there could be compromise with the confidential data, the in aerospace, it is utmost important that we secure the systems against the malicious attack to make sure that they are safe, because the lives matter. I'll take you through some of the examples on how in the new world with the increased connected aircraft, what are the different vulnerabilities that are there, and how are we looking at securing them, right? So first, let us look at the air traffic management. In the very first slide, I talked about how the urban air mobility space is getting defined, right? But that is new. Even if you look at the existing aerospace air traffic management system, the data communication have been evolved decades ago. Some of these systems are built decades ago, right? But now, initially they were just papers, there were voice commands, but the increase in air traffic, more and more things are getting digitized. And these communications from aircraft to air traffic controller and even the ILS and navigation system are not really encrypted, right? So there is a possibility of these systems getting hacked, or you can have fake messages coming in wherein the aircraft is not able to differentiate, the air traffic controller is not able to differentiate between the right message or attack message, right? That could actually lead to aircraft not landing at the right location. That too, if severe weather is there, pilot is not able to see, it could actually lead to a very significant challenge in the safety, right? We are looking at new networks with low Earth orbit, if and that will enable complete internet availability, that to high speed inside the aircraft. Right? How are we gonna secure those things? Securing it would require you to have an encryption mechanism built in. It will require authentication built in. It will require identification of the message from the right source. Right. So there are multiple techniques that would require, and we'll have to also define clearly whether it is a threat and how it needs to be handled. Right? There are, given the same operation at an aircraft system level, the ADSB messages, they are used, to detect a collision avoidance system, for example. Right? And if those messages are again hacked and they are not getting the right message, malicious message, it could seriously compromise on terrain collision avoidance system, for example. Right? There are, in an overall aircraft, communication happening from satellite, communication happening from the ground network, and also there are interfaces which are happening with air-to-air communication. And then you have the ground network where the airline gateway comes in and a lot of data gets connected, right? So there are more and more interconnected systems. There are, all of these are being evolved as a single architecture. So lesser and lesser isolated systems, isolated federated architectures. You now have integrated modular avionics. All new aircrafts would have integrated IMA instead of a federated application. And not just that, now you're looking at the whole connected aircraft as such, with the ground communication, with the aircraft, and what happens within the aircraft, right? And lot of the different kind of networks are involved. Things are stored over cloud, right? So instead of a local in-prem, there are things stored over the cloud. There are software updates which are going to be required over the cloud, right? So when all of these happens, more and more vulnerability are exposed. There are more reachable targets from security perspective, right? So how do we go about what the system has thought about, what FA, what the aviation community has thought about, how do we secure it, and what is the level of security that is really required, and how do we secure all of these systems, right? So international Air Force communities are looking into it. There are different forums, active forums. There are ICAO General Assembly has adopted a cybersecurity strategy. And one of the key elements, one of the key things which is a DO 326A document was released which was with a special committee, an European version of this is ED3 202A, which is the airworthiness security process specification. Right? Now, going forward, this is going to be the only acceptable means of compliance by FAA and ESSA. And to be able to, a few more things that I would like to highlight here is this document has to be used in conjunction with the other ARP system safety assessment document that we have, the DO 118 document that we have, right? So the entire flow and entire document and what is required to be done is an integrated view. And also this is for type certification applicable for type 25, right, which is greater than 90-seater commercial aircraft, right? So, however, the similar methods can be adopted for other certification, but as far as DO 326 is concerned, it is only for type 25. Right? So let's look at what do we have here in 326. This is going to be the de facto document, de facto standards, de facto guidance that going forward we'll be using for certifying a new aircraft, new system, or even a modification to aircraft and system. Right? So this would include certain activities which are integrated part of the respective ARP documents and respective other DO documents, DO 118, DO 254, but it also has some certain documentation, certain evidences which are very, very security, very, very cyber security specific, right? So I'm going to talk about more of those specific details and how it interfaces with the existing documents in subsequent slides, right? So let's look at 1, 2, 3 start. Okay, let's look at in terms of airworthiness DO 326 framework. What does it recommend? Here, there are activities which are certification related. There are activities which forms the basis for the certification, which is the security risk assessment. And then there are activities based on the risk. How do you incorporate and develop the security into your architecture? What are the things that you have to consider, and how do you assure the security? So those are all the 3 blocks that we need to take care. First block will require planning and then the scope definition of security. A lot of these guidance is available that includes ISO 27005, and the key element here is you need to start with the security risk assessment, right? So security risk assessment includes your threat analysis, threat conditions, and describing those threat scenarios. And then you will have to say whether these security risks, what is the severity, what is the impact, right? One key element in doing any other security risk is here you'll have to integrate it with the safety. And that will require you to categorize the severity in terms of catastrophic or there's no safety risk, right? Once that is determined, the impact would be here in terms of integrity, in terms of availability of the system, in terms of confidentiality, where the data which is not required to be accessed is getting accessed, right? So all of this will get into a acceptability matrix, basis which will determine whether security risk is acceptable or not, and accordingly the associated architecture or security consideration has to be implemented. So the entire development process, as described in DO 326, to make it effective, has 2 key elements. One is the integral process, which is a continuous process to develop the safety assessment and ensure that the assurance of the security aspects are taken care together, right? And then there are aircraft level and system level development process that happens in a Just like in a waterfall model development, you develop hard system requirements, then you develop hardware and software requirements, and then you implement these requirements into security requirements, get into aircraft safety hazard assessment process. It gets into the system requirements. It gets into allocated to hardware and software, and then as part of that, the architecture gets validated, and the requirements are updated, and it goes into implementation. Right. So these are all the development activities. Now coming to the top block that you have here, which are implementation of security risk assessment and verification and assurance of that. Right. So there are two aspects here. One is the development assurance, and another is security effectiveness assurance. Development assurance will happen by validating and verifying those requirements, whether it is for the function, the plan based on the risk assessment, your mitigation strategies to denial algorithms, authentication algorithms are incorporated, even as good as CRC checks are incorporated in the system architecture. Is that correctly incorporated? We are correctly testing it, right? So that's one part of the assurance. Second part of the assurance will have security effectiveness assurance, which will include whether the configuration management of the entire process is correctly done. Is it secure? Because in the cloud environment, you will have to make sure that the code written out there, the entire access control, the entire configuration parameters are correctly handled. Right. So that is the effectiveness insurance, and both of these has to be evidenced and given for the certification authority for assurance. So looking at that, the safety aspects and the aircraft level requirements go hand in hand. And in this slide, we have documented how the aircraft product level, which is the existing ARP requirement, and the interface with the security risk assessment, they go hand in hand. Right? You define the requirements, you do the security risk assessment, you pass on the same requirements for the functional safety hazard assessment. Right? Based on the functional safety hazard assessment, there is a category of implementation which is allocated, whether it is a software requirement, hardware prevention mechanism is at the software level, hardware level, implementation happens, and overall the development security of security requirements also happens hand in hand with the system safety and with the hardware and software associated development. And one key element here in certification of in validation of aircraft security, it includes your system security, it includes your network security, it includes the overall IT security aspects as well, right? So now you'll think about we talked about security scope definition, we talked about secure system assessments, we talked about vulnerability, we talked about threat analysis, we talked about validating it. But what is it that we are doing with respect to system security, network security, and IT security, right? So IT security is important, and today it is already being implemented very much in the aerospace world, right? In the IT information security, that the implementation is there. But the key in this IT security aspect is based on how you do the overall risk assessment. There are elements that is not going to be incorporated or implemented as a software or as a hardware as an encryption mechanism, right? There are items like for maintaining the system, when a maintenance operator does the maintenance, there are vulnerabilities out there which has to be taken care as part of the system level operator guidance or system level security operator guidance. And similar aircraft level installation security guidance has to be given out there like a manual. In addition to how you install, you'll have to also take care of how you will install the same securely, and what are the vulnerability you need to take care, right? Second aspect comes as a network security, right? In the network security, in the aerospace world, there are unidirectional, which are probably much more easier to secure because it's a one-way communication, like ARINC 429 does, right? But still, you will have to define what are the parameters, what are the risk based on the threat. All these documentation and the testing validation has to be done, right? And then you will also get into the bidirectional security systems, right? Bidirectional network systems like AFDX. Today in the AFDX, it's bidirectional, so we will have to do a proper assessment of how both the ends of communications are secured, right? There are certain elements in the AFDX security which is actually built in. Third part, how you assure the system security is your security requirements are there in the high as part of the hardware security requirements. They are there as part of the software security requirements, right? So as part of your standard development process, you test them. You test them for the normal functional intended behavior, and you also do the robustness testing. So that is regular, like you will do it for any requirements. But one security specific validation and verification which will be required here is the vulnerability testing, vulnerability validation. So based on your risk assessment, you have all the vulnerabilities. Now, I would say an ethical hacker, you will have to look at breaking the system, doing the vulnerability testing, right? And then you will have to document that as an evidence. So that is an extra additional element that is required to be done. So now I will talk about in any today we have in any software development DevOps, right? DevOps requires you to update the software and develop the software in a continuous integration and build environment, right? What I'm adding here, that what is a good coding practice, good development practice for a new development is to make sure that we integrate DevSecOps, right? So as and when you develop, you'll also have to make sure that the security aspects are also taken care, because a lot more of these softwares are going to be now in the cloud. You will require to be able to make the patches and updates over the cloud, and that too securely, right? And you will have to have a mechanism to roll it back as well in case of a security flaw, right? So all of this and proper authentication is happening, proper encryption is happening, has to happen while you develop a new product, right? So this is one key aspects which we should not make a security an afterthought, and it's going to be a much more work, when the new aircraft program comes in, looking at the documentation and looking at the whole new safe and secure connected aircraft world, we'll have to do it. It could cost a lot more to develop a new safe and secure aircraft, right? But the key to make sure that it costs right and we do the overall development in the right manner is, it's not do a cybersecurity that it is somebody else's job. Someone else will come in and then they will do a completely different set of documentation, some completely different set of development. No, the entire development process has to be together, and as part of the DevOps, you will have to do DevSecOps, and that's the key in the aerospace world for a new product development. However, coming to the aerospace specific world, the key element here includes defining the whole security environment. Right? Whole security environment is, you have your air traffic management, you have aircraft, you have systems within the aircraft, right? From where what kind of attacks can come in. So you'll have to look at it a holistic view. Security parameter is the aircraft, security parameter system is a system, right? So we'll have to make sure that the security measures are not just incorporated as part of a deterrence, right? Somebody attacks, you will have to make sure that you display authentication failure, you display warnings, so that's a deterrence, right? Then there is a detection. if certain attack happens, we are able to detect it, well and good, right? So, but even if attack happens, and then we will have to make sure that we are able to recover from those attacks. That's another aspect of it, where recovery plays. The availability of the software. In the aerospace world, you always have fail-safe mechanism, and this is kind of another fail-safe mechanism that will trigger in. And beyond that, there will be corrective action, preventive action that includes documentation, upgrade, manuals, all of those. Incorporating a new firewall mechanism. And that's where you see at the bottom. There are technical measures in the system, but there are other measures that are required to be done as part of the procedural, policy, people training aspect as well, right? So this ends this session.